In MIG welding, there are several methods used to strike an arc and initiate the welding process. The choice of method often depends on the specific MIG welding machine and the welder's preference. Here are some common methods. Tapping or scratch start. This is the most basic method. It involves physically tapping or scratching the tip of the welding wire against the workpiece to create a short circuit and initiate the arc. Once the arc is established, the welder withdraws the wire slightly to maintain the desired arc length and begins the welding process. Push button or trigger. Start. Many modern MIG welding machines are equipped with a trigger or push button mechanism on the welding gun. When the trigger or button is pressed, it sends a signal to the welding machine to initiate the arc. Releasing the trigger or button stops the arc. High-frequency start. Some advanced MIG welding machines use high-frequency start technology. When the trigger is pulled, the machine generates a high-frequency electrical discharge near the tip of the welding wire, which ionizes the air and initiates the arc without physical contact with the workpiece. This method is often preferred in situations where the workpiece's surface should not be contaminated or scratched. Lift arc or contact start. In the lift arc or contact start method, the welding gun's nozzle is brought into contact with the workpiece. When the nozzle touches the workpiece, the circuit is completed and the arc is initiated. This method is commonly used when welding materials that are sensitive to surface contamination or when the welder needs precise control over arc initiation. Remote control initiation. Some MIG welding setups may use remote control devices or foot pedals to initiate the arc. The welder uses the remote control to trigger the welding machine to start or stop the arc, providing them with greater control over the welding process. The choice of arc initiation method depends on the welding machine's features, the welder's experience and preference, and the specific welding application. Each method has its advantages and limitations, so it's important to select the one that best suits the job at hand and ensures a safe and controlled start to the welding process. Gas metal arc welding, GMA, involves the use of electrical polarities to create and control the welding arc. There are two primary polarities used in MIG welding: direct current electrode positive, DCEN or DCEP. In DCEN, the workpiece is connected to the positive terminal of the welding power source, while the welding electrode, the wire, is connected to the negative terminal. DCEN is often used when welding materials that require deeper penetration, such as carbon steel. This polarity generates a more stable arc, which concentrates heat on the workpiece, and is often preferred for certain welding applications. Direct current electrode negative, DCEN or DC. In DCN, the workpiece is connected to the negative terminal of the welding power source, while the welding electrode, the wire, is connected to the positive terminal. DCN is commonly used for welding materials like aluminum and stainless steel, which have a higher thermal conductivity. This polarity allows for greater control over the weld puddle and helps prevent burn-through on thinner materials. The choice of polarity depends on the material being welded and the desired welding results.